Hello world, welcome to CyberCreed, and today in this video we are going to see one of the most popular arrays question, the to-sum. This question has been asked by many product-based companies like Google, Facebook, Yahoo, and this is one of the most interesting arrays questions too. So we are going to solve this question in three different ways with the three different time complexities, and then we are going to analyze which of the time complexity is the best one. And if you are new to our channel, you can just subscribe to our channel to get the content like this. So let's just start. So here on the question, you can see that you are given an array of integer nums and an integer target. We have to return the indices of the two numbers such that they add up to the target. And we have to assume that the input would be exactly one solution, means we have the solution in any case, and you may not use the same element twice, and we are not allowed to use the same element twice. So you can return the answer in an order, means we have to just return our answer in any order. It can be the 0 1 or 1 0, the order does not matter here. So let us just take up this example, which is 2, 7, 11 and 15. So here you can see 2, 7, 11 and 15, and you are given the target as 9. So the target is 9. So when we are going to just sum of this 2 and 7, we are going to get this 9. 7 plus 8 plus 9, it is 7 plus 2, it is 9. So here we can see that the indices are 0, 1, 2 and 3. So the two numbers that sum up to give the third number, that is our 9, their index are 0 and 1. So we simply return 0 and 1. So here you can see that the output is 0 and 1. And let us see the another question. It is 3, 2 and 4, and the target is 6. And here the target is 6. So we can simply see that adding 4 and 2, we are going to get 6. And the indices here are 0, 1 and 2. So here we can simply return 1 and 2. Till now I understand that you might have got our questions cleared. So now let us just move on to our first approach, that is basically going to be the brute force approach. And this is the most easiest approach which you are going to have while solving any kinds of problems of generally the array. So let us see that. So let us just first see the simplest solution, that is basically going to be our brute force approach. So in brute force approach, what we can do, that suppose that we have our number, let us simply say 1, 2, 3, 4 and 5, and we want to find the target sum, which is 7. So by looking here, you can simply say that 4 plus 3 is going to be 7. How we are going to use the brute force approach? First, we can simply use two loops. So first loop will just point to our first index, then we will start second loop, and the second loop is going to just go through our all elements 1, 2, 3, 4 and 5, and it is going to check 1 plus 2, is it equal to 7? It is not, so it is going to continue. So 1 plus 3, is it equal to 7? It is not, it is going to continue, and like that it will perform the checks with all the numbers except itself. So we have to not take the number itself. This is already mentioned in our question. So again it will start with 2, it will take 2 and it will check with 1, it will check with 3, it will check with 4, it will check with 5. So 2 plus 3 is not equal to 7, 2 for 4 is not equal to 7, 2 plus 5 is not equal to 7, so it will move on and it will go to 3. And once it reaches 3, it will check with 1, 1 plus 3 is 4, 3 plus 2, 5, 3 plus 4 is 7. So here it will find a match, 3 plus 4. And it will simply return the index. So the first loop will be like, for our I loop, I is equal to 0 till our n, and the second loop will go from for j is equal to 0 till j is less than n. So we can see here both I and j are pointing to the indices of our array. So we can simply return both I and j, and it will return like 0, 1, 2, it will return 2, and it will 0, 1, 2 and 3, it will return 2, 3, and we can simply return this. So this is the first way, and here we are having the two loops. So the time complexity of first loop is going to be big O of n, and this one is also going to be big O of n. And as it is nested once inside other, so we can say here that once you see that two loops are nested inside one another, we can simply multiply this big O of n into big O of n. It is going to be big O of n into n. It is nothing but big O of n square. So this solution is big O of n square with the time complexity, and you can see here that we are not storing anything. So our space complexity is going to be big O of 1. So this is the most simple approach. If you come with this, it is fine. If you are beginner, it is expectable. But now let us move on to the most optimal approach, which is better than this. So in that approach, we can simply take our example 2, 7, 11 and 15. Let us simply take 2, 7, 11 and 15, and let us just say that our target is 18, and we can see that 7 plus 11 is going to be 18. So how we can decrease this time complexity? And when we are trying to decrease the time complexity, most of the time we have to just use extra space to just decrease our time complexity. And in the most of the cases, the best data structure that comes up is our Hashmap. If you are using Python, it is dictionary. If you are using C++ or Java, it is Hashmap. So how we can use Hashmap here? So let us see. So here with the Hashmap, what we can do, we can basically calculate the difference between both of them. Like 18 minus 2 is basically 16, and then we can simply perform a check that if 16 is in our dictionary or not, and if it is not, we can simply continue, and then we can check 18 minus 7 is 18 minus 7 is equal to 11. Is 11 in our dictionary? If it is available, then we can return the indices, and if it is not, then we cannot. So let us see it step by step. So first of all, we are simply going to initialize an empty dictionary. Don't worry, we are going to have a look at the code, but for here, just let me explain with this. So here we can initialize our empty dictionary as D. Then we can simply do the subtraction of 18 minus 2, and then we can check if 16 is in our dictionary or not. So 16 will not be in our dictionary. Dictionary is initially empty, and if it is not, then we are simply going to add our element to our dictionary. Then we can simply add 2 and its corresponding indices. So with 2 as a key and 0 as a pair, we can simply add it like this, and then it is going to move forward, and in our dictionary we have 2, and then it is going to do the same operations like 18 minus 7, and 18 minus 7 is nothing but 11, and it is going to check if 11 is in our dictionary or not. So in our dictionary D we have just 2, we don't have this 11, so we are going to do nothing but simply going to add our 7 to our dictionary. 7 is added here as a key, and our indices like 0, 1, 2 and 3 is basically going to be added. Like for 7 it is 1, so in our dictionary we have 2 and 7, and then it is going to move forward to 11. So once it moves forward to 11, it is going to do 18 minus 11. 18 minus 11 is our 7, so it is going to check if 7 is in our dictionary or not. So here we can see 7 is there in our dictionary. Then what we can do, we can simply return the indices of this 7, that is 1, and the indices that we currently found it. So we currently found our element at 2, then we can simply return 1 comma 2 here, and then this will be our answer. So in this case, what is the time and space complexity going to be? As you can see that we are just traversing our arrays once, so we are just using a simple loop, a single loop which is going through all the element, and thus our time complexity is going to be big O of n. But you also have to remember that you are using extra space for solving this problem in less time. So here we are using a Hashmap, and you can see that in worst case Hashmap is going to store all these elements. So we can say that the space complexity is also going to be big O of n. So we are able to decrease the big O of n square time complexity to big O of n by using extra space. So it is the most optimal solution regarding the time complexity. But here we can see that we are taking extra space. So now we are going to see our third logic, like can we do better than this? So with the respect to time complexity, no, we cannot do better than this. But with respect to space complexity, we can do something. We can make it constant. And now let us see how we can make it constant. So let us take our same example. Okay, now let us check another way of solving this problem. So let us see that we are given an array. We can simply use sorting. So here on our given array, it is already sorted. 2, 7, 11 and 15 are already sorted. So let us just suppose that we have sorted the array. The array is not, so it is not mentioned anywhere that this array is sorted. So we have our number 2, 7, 11 and 15. So by luck we have this sorted array, and our target is going to be 9. So let us see how it is going to work. So first of all, we need to sort our array. So we sorted our array, then we received 2, 7, 11 and 15. So once we have this 2, 7, 11 and 15, what we can do is that we can use the 2 pointer algorithm. The first pointer is going to point here, point at 2, and the second pointer is going to point at 15. So what does this pointer says? So this pointer basically indicates that this is the smallest number and this pointer is pointing to the largest number. So here what we are trying to do, first we are trying to sum up this 15 and 2. So first it will just add 15 plus 2, then it will give 17. Then it will compare, like if 17 is greater than 9. So here 17 is greater than 9. So what steps we have to perform? So here we are getting a number that is greater than our target value, that is 9. So 17 is greater than 9. So here we know this array is sorted. So if we are going to move this pointer to the left, it is guaranteed that we are going to have the sum which is less than our previous element. So we just simply remove this pointer from this side, and now we are simply going to just point to this 11. So now we are pointing to 11, and now we repeat the same process. So here we just sum up 11 plus 2, it is going to give 13. So it is 13. Now again we are going to compare. If 13 is greater than our target is 9, so here the condition also satisfies. So our pointer is now going to just move to 7 now. So now it is going to check 7 plus 2, it is going to be 9, and it will return the indices of both of them. So now let us just take a little bit different example where I will be able to show what happens when we encounter sum that is less than our target value. So when the sum is less than the target value, then and only then this first element will move. So let me just quickly show you with an example. So let me take another example, that way I will be able to make things more clear. That will be 2, 4, 5, 8. Of course the array needed to be in sorted order, and then we have our 9. And let us say that our target is, okay, let me make it 19. So here is our array 2, 4, 5, 8 and 19, and our target is 9. So in order to solve this question, we are going to perform the same step, but here we can simply see what is going to happen when we encounter the sum that is just smaller than what we desire. So here our first pointer will be here and second will be here, and 19 plus 2, it is going to be 21, and 21 as you can see is greater than 9. So this pointer is going to move to 8, and here it will not be there. And then 8 plus 2, it is going to be 10, and 10 is greater than our 9. So then again it is going to move to this side. So here it won't be there, it will come here. So now we can see 5 plus 2, it is 7. 5 plus 2 is 7, and it is less than 7 is less than our 9. So in the case when it is less than, then we need to move this pointer to the next step. So let me change the color of this pointer. So this pointer is moved to this. So now we have our pointer 1 pointing to 4, next pointer pointing at 5, and now we sum up 4 plus 5, which is equal to 9, and then we found the sum. We are simply going to return this index of this 4, which is 1, and this 5, which is 2. So these are the three ways that we can simply solve this question. But let me just quickly analyze this time complexity of this algorithm. So this algorithm, first we need to sort. So first we are simply sorting. So if you take any algorithm that is basically meant for sorting, either inbuilt or you are simply going to implement it by yourself, then it is going to take big O of n log n time. Here this is our basically the time complexity, and the space complexity here we are not storing anything, so the space complexity is basically going to be big O of 1. So let us finally analyze this. So first solution that we got was with big O of n square time complexity and big O of 1 space. And the second solution that we discovered was having the big O of n time complexity as well as big O of n space complexity. So it was having both space and time complexity equal. And the next solution that we arrived was big O of n log of n, and the space complexity was just big O of 1. So these are the three solutions, but for this video we are simply going to implement this solution, and if you understand how we are going to implement this, you can basically implement any of the above solutions or the below solutions. So let me jump to my editor and let me show you. Okay, so here it is the same question. You can find it, the link will be in the description below. So first of all, we initialize an array which is just simple empty array. It is basically used to return this, because here you can see that the output is inside an array, and that is the only reason we are using this array. And then we are going to initialize this empty dictionary, and then we are going to just loop through all the elements in our array. So we are going to loop through 2, 7, 11 and 15. And while we are looping through this, we are simply going to find target minus num of I, and what it is basically doing, it is basically checking 9 minus 2, which is 7. Is 7 there in our dictionary? So till now dictionary is basically empty, so it won't go here, and if it won't go here, it is basically going to add this to our dictionary. So the 2 num of I is basically 2, and 2 is going to be added with the index which is basically 0. So 2 0, as we have seen here in our case, we have 2 0 and then we have 7 1, and in next we found 7. So target minus num of I, which is basically going to be 9 minus 7, it is basically going to be 2, and 2 is present in our dictionary. So if 2 is present in our dictionary, we are simply having I, means it is the current position, like it is of 7. So 7 is having I, which is basically 1. And then we have D of value, which is basically the index of this 2. So here target minus num of I, so target was 9, so we can simply write it here, so make the things clear. 9 minus 7, which basically gives us 2, and so the value stores 2, and D of value means D of 2 is basically storing the index of this value, which is 0. So it is going to return 1 and 0. Our program will simply come here and it will just return this A, which is having this value. So let me just simply submit this code. And the time and space complexity, as we have discussed here, is that it is having big O of n time complexity as well as big O of n space complexity. So this was it for this video, and I want you all to just try to implement all of the solutions that I have mentioned to just increase your creativity level. So it is not that everyone is an expert, everyone is going to just write the code and it is going to simply execute it. You can see here that I also fails many times, I also get wrong answer, but if you keep on trying, you are going to find an optimal solution, and that is how we learn. So thanks for watching this video, and if you enjoyed watching this, please make sure to like our video and do not forget to subscribe to our channel to great contents like this. Either it's related to data structures and data science, we are going to provide everything in detail. So thanks for watching once again. Meet you in the next video.